So we're going to spend the evening looking at factorization. Right? I think some books, Americans want a Z there, right? Yes, I think so. All right. One second. All right. I'm trying to write a Z. Yeah. Um, so I think last week when we ended the class, I introduced this idea of using the distributive law. And if you remember, I was saying that, okay, you can take this and you multiply A by everything in the bracket, and you get this. I was saying, okay, while we're used to doing this forward movement here, where we take this and multiply everything in the bracket, or remove the bracket, as some people say. So we use the distributive law in this direction. We can also use the distributive law in this direction. You look for the common factor, which in this case is A, pull it to the front, and you divide each term by the A and put it in a bracket. So AB divided by A gives you B. AC divided by A gives you C, right? And that's the distributive law being used to factorize, um, an algebraic expression. So we're gonna concentrate on this today, right? We're gonna concentrate on this particular thing. I just want to review some of the examples I shared with you last week. For example, okay, if you wanna, let's go with 2x squared plus, let's say, 4x. You know, you have to factorize that. You look for the highest common factor, which in this case is 2x, right? 2x squared divided by 2x gives you x. 4x divided by 2x is 2, and that's it, right? Remember that from last week?
Yes, sir.
All right, let me
I think, sir, sure we did one like that for last week.
yes, isn't that what we end off the class with?
I'm looking here for it, and I mean, I would have made some notes.
All right. Let's see. Let me see something.
There's one similar to that, not the exact one.
Yeah, I know it can't be the exact one. I mean like that. Yeah.
Yes, sir. Mhm.
I
Yeah.
just want to know if the guy. I got it wrong in that I didn't
No,
talk
because
about
I'm looking through my
factorization.
notes and I'm not
Oh, you're not seeing. Okay. Let me
yes.
just check. Let me just check the recording I put up. 1 second.
Probably you did it or I missed it.
Yeah, it's possible. Let me see. Let me see the. Um, this is a course here, right? So, let's see. This is a video for last week.
I have it in my books, sir.
Yeah, look here, look here. I was doing. Yeah, y'all see this here? This is last week video. You remember this,
Yes,
sir?
sir. I recall that.
Yeah,
Yes, I
yeah,
recall that.
yes. And we did factorize by grouping.
Yes, the factorize by grouping.
Yes. So that's last week, right?
Yes.
Yeah. So, okay. Uh-huh. Yeah, I remember somehow we went through a few of those, right?
Okay, sir.
Yeah. Um, good. So this week, what we're going to concentrate on is some deeper application of factorization. In particular, we're going to talk about what we call quadratic, quadratic expressions. And well, we'll get on to we will move on to quadratic equations, right? And how to solve them using factorization, right? Factorize. Yeah. And we'll keep using the S. There's this debate among the Americans and British about S and Z, right? Let them fight about that, man. If it's a Z or an S, right? Change it to a Z before anybody find fault. Yeah. We're yeah. So what's a quadratic really? What's a quadratic? We borrow a little definition from. I wonder why. Good. So this is a nice little definition of when we talk about a quadratic, what we mean, right? So a quadratic expression is an expression of that form. Ax squared, as you see here, ax squared plus bx plus c, right? Um, the term, the coefficient there must not be zero. You can have b being zero. You can have a quadratic without that term. You can have that, right? Give you a little hint as to why they call it a quadratic, right? I'll give you a little hint as to why they call it a quadratic. Quadratic. Let me just move it aside. So if you have an expression like this, right? You have an expression
Excuse me, sir. Please
x.
put back the thing. Please put back the
Oh,
slide.
you want okay. You got it there?
Yes, sir.
Okay. Yes, I'm happy to hear that people are making notes. I'm trying to remember if it's this class I spoke elaborately about note taking, especially with pen and paper, how good it is for one's memory and learning in general, right? Um, Sometimes you say, man, I gotta watch back the video, man, and you don't get the time, right? You don't have the time, and then sometimes you open the video and the video is so long, man. You see, when we are doing the class here, I'm right here, right? And I call out to you and I interact with you, and you're motivated to stay on. But when you watch a video, you halfway, you say, me able to watch this no more, you're gone, you know? So it's good to make some notes. Um, as I mentioned before, right? Note taking, especially with pencil or pen and paper, aids memory, right? And it's far more effective than, just passively listening and say, oh, I'll look back at the video and so, right? I'm happy that that guy just now, he noted down something different. And, that part he couldn't remember. And so it's good question those things, right? So it's good you all are paying attention and so, right? So let me get on to this matter of why we call the thing a quadratic. So let's say we have an expression, x plus 2. Now, this expression, I think I should make it a little bigger. Yeah. This is what we call a binomial, right? The reason why I call it a binomial, it has 2 terms inside, right? 2 terms. You call it a binomial. If it had 3 terms, you call it a trinomial, right? And so, right? So if you take this binomial, and let's take another one. Let's go with maybe x minus 3. So this is a binomial, and this is a binomial. And if we were to multiply these 2 binomials, let's see what we'll get, right? So how are we going to do it? We can take this multiplied by x. So we have x times x plus 2, then minus 3 by x plus 2, right? So what are we going to get? We're going to get x squared plus 2x minus 3x minus 6. And when we simplify that, we get x squared. This is going to be minus x minus 6. So even though there are only 3 terms, right, in this expression here, it's a trinomial. It's also called a quadratic. The reason why is that it's the product of 2 binomials, right? It's a product. Yeah. Yes, Salona.
Sir, how you get the x in front of the bracket? Or the x, where the x come from?
Well, okay. When this means this here multiplied by x minus this here multiplied by this whole thing here. Let me go back to the let me go back. No, let me go back to this. I want you to see the similarity. What do? You take A and you multiply it by B. Isn't that what you do? Plus A multiplied by C. Isn't that what you do? So in this case, A is this whole thing here, right? And B plus C is this whole thing here, right? So all I'm doing here, I'm taking B, right? B here, and multiplying this whole thing, right?
Excuse me, sir.
Yeah.
Good afternoon. Just tell me if I'm going wrong, all right. Is x times x and x times 3? Is it? It's like that? I don't know.
Where is that?
And
here?
yes, it's how you're multiplying it.
X by
times
x squared.
x
X by
times
2, we
right.
get 2x. Yeah. Yeah.
Okay,
Right?
I was thinking it a different way.
Yes.
All right.
If this is confusing you, you could also write this as, you can write this as x times x minus 3 plus 2 times x minus 3. It's the same thing, right? You'll get what? X by x, you get x squared.
Well, I understand it this way, sir.
Yeah, x by minus 3, you get minus 3x, right? Plus 2x minus 6, right? And you get up with the same thing, x squared minus x minus 6. Either way, the whole idea is just like you take what is in front of the bracket here. In this case, it's not just A, it's a whole expression, right? And I multiply it by this. I didn't put the x behind. I know the B is behind. right? And the C is behind. The reason why we write this way is just because the letter A and B, A come before B, so I put A before B, right? So, well, the idea is that I multiply everything here by X, and that's what I'm doing here, right? And then I multiply everything here by minus 3. That's what I'm doing here, right? And you simplify. For those who that logic is confusing, then you can do it the other way, right? You take this X times everything here, and then this 2 by everything there, right? And that's what I have here. Either way. And there is even a shortcut, right? Before I go to the shortcut, I just want to highlight that the reason why we call, and I think I said it before, we call this a quadratic. It is simply because it's a product of two binomials, right? Binomial, by, or 2 by 2 is 4. That's why we say a binomial by a binomial gives you a quadratic, right? Because quad means 4, right? Let me give you a shortcut to multiply, right? And some people like this. X plus 2 times x minus 3. Some people do this. X multiplied by that and x multiplied by that, right? And you get x squared minus 3x. And then you go 2 by x, 2x, and then 2 by minus 3, right? And you get that.
Yes, sir. This is the way I was telling you about.
Yeah. Well, yeah, these are just shortcuts. I wanted you to see the distributive law at work. And that's why I was going with this here, right? I wanted you to see the distributive law at work, right? Either you do it this way or this way. In both cases, you are applying the distributive law, right? You are applying the distributive law. Whether you want to take everything here and multiplying by each of these here, or you take everything in here and multiply by each of these two things in the second in the first bracket. That's what we do here. Regardless of which method, they both turn out to be the same thing, right? It's a distributive law at work, right? It's good to see how you build. You know, we're building mathematics based on the axioms that we talked about at the beginning of the course, right? These other things you see where people show you shortcuts and so, these are not mathematical really. These are just patterns people observe and say, you know what? This is a quick way to get the thing, right? But to really understand the mathematics, it is very important that you see how the axioms, the rules, right, are used. If you don't get the rules, you're not really going to learn mathematics, right? These kinds of things. I'm not criticizing if you were taught these things and so. You know, these shortcuts. Remember when we talk about equations, right? X plus 2 equal 5. Some people say, take the 2 over there and change the sign. You get x equal 5 minus 2, x equal 3. This is not mathematical really, right? This is some shortcut people observe that they can do, right? So there are those who are right. I mean, most of us, we want to be able to do mathematics to get by and get by fast. Then is when these shortcuts come in, right? This shortcut is, it comes in very handy. But for those who, you know, they really want to use mathematics to develop their, you know, cognitive processes and perhaps to even add to the mathematics knowledge and so, it's important that we understand the processes. How do we build on the ground rules, the axioms that we, you know, we started off mathematics with? How do we build on that? So that in the end, if we do create anything new in mathematics, it doesn't contradict any earlier ground rules, right? Axioms are basically like rules that we set out, right? We can't contradict those at all. So while these shortcuts are good, They help you get the answer fast. But you know, if you understand the logic, you'll get a deeper understanding of the mathematics. And I'll show you now how, all right, how understanding how you expand this is important in understanding how to factorize the expression. So let me deal with that. Let's talk about that. So I'm going to remove this because I don't want any confusion, you know. Yeah. So I took this, right? What I'm going to do, I'm going to do it a little, I want to do it even longer. Because we're going to learn something from the process of expanding the brackets and simplifying how to factorize, right? So this here, all right. So we said, no, you have to remove that, you know, or else that wouldn't come out. Yeah, so we said, okay, that is equivalent to x plus 2 minus 3 times x plus 2, right? Chandel or Chantel, or erase this thing here. Yeah. So when you expand this now, look at what happens. You get x squared plus 2x minus 3x minus 6. And then when you simplify, you get x squared minus x minus 6. Good. So understanding this expansion process would help you now to understand the factorization process, because the factorization process now is the other way around. But to take this, right? We want to factorize this. So we got to go and get that back, right? So how do we move from here back here? Well, by observing what's happening in this process, you know, what's happening here will lead us back there. You understand why it's important to understand this? Because now you're going to be helped to, well, if you're given this and somebody says factorize this, meaning write it back like this as a product of its factors, right? And what you're seeing here, watch it good. There's a process where they tell you that, look for two numbers. Look for two numbers. When you add them, you get minus 1. And when you multiply them, you get minus 6. And watch here. Do you see that? 2 and minus 3. When you add them, you get minus 1. And when you multiply them, you get minus 6. So you rewrite this expression with the 2 and the minus 3. With the 2 and the minus 3. You rewrite this expression like this. So we kind of split this middle term. We split this middle term into 2. Into 2x minus 3x. It's the same minus x, right? But we do it for a purpose, and you'll see the purpose just now. So we write this back like this. Our next move now is to do this step, right? And I think we can even insert a step here. I don't know if you can see how we jump from here to here. It's like we pair off these two and factorize out the x. It's like, okay, let's add in this step here. X squared plus 2x. Put that in bracket. And then minus 3x plus 6. Right? I remember last week we talked about why when you put a minus here and put a bracket, this sign has to change in here. Right? So with this now, we can now factorize out x. And down here, factorize out minus 3 now, right? And after we have done this, we know we apply the distributive law one more time. X plus 2 is common. So we pull it to the front. And in the back bracket at the back here, you put x minus 3. So you see why understanding the expansion process helps you to understand how to factorize. You think you're getting why that is important? So while the shortcut, yeah, it's good. It helps you to get by quickly. right? It doesn't help you to understand the logic that you can reverse engineer this thing now and factorize the expression back, right? Keep that in mind. Very important. We're going to do a few examples. So take some time to digest that, right? Let's see if we can do a couple more. Can I move this out? Good. So,
Yes, sir.
all right. So let's say we want to factorize x squared plus 5x plus 4. In fact, we want to factorize something like that, right? We are going to follow that same method just now. We look for two numbers, and maybe you could call them P and Q, right? Look for two numbers, P and Q. And P plus Q must be equal to 5, and P multiplied by Q will be equal to 4, right? Usually it's the number at the end here. By extension, and we'll go into some like that, it is really P times Q must be equal to the number in front here, right? Times the number at the end. We can come to those later on. As of now, the PQ, right, must equal to the number at the end here. And that shouldn't be hard, right? Could you tell me the two numbers? Could you think of two numbers? What can P be and what can Q be?
Both could be 2.
2? 2 and 2 would add to 5?
On screen, sir.
3, sir. 3.
3,
3 and what?
2.
3 and 2 would multiply to give you 4?
No, sir.
Sir,
No, sir.
4 and 1.
4 and 1.
4
4
and
and
1,
1.
yes. So you can, all right, you can say P is 4 and Q is 1, all right. You can do it the other way around too. Good. So now we can rewrite this, right? So we're going up here now. We rewrite 5x as 4x plus x. Same 5x, right? So this is equal to this plus 4, right? So we use the 4 and the 1. We don't normally write 1x. You all know that, right? Good. So next we could pair them off. X squared plus 4x, right? So put that in a bracket plus x plus 4, right? And now we can further factorize it. What's common here? X. So we get x plus 4. Down here, what's common? 1. So we get x plus 4. Again, we can further factorize because x plus 4 is common. We can pull that to the front, right? And put the other, what is in front of the brackets, the common bracket, in one bracket like this, right? So you see how it's done? But understanding how we expand something like this to get this is so helpful, right? It's so helpful. Digest it a little there. We'll do another example or so. All right. Let's take another. Say you want to factorize x
Sir, can you please
squared.
come back a little bit?
Uh,
Can you please come back, bring back the equation on the screen a little bit, please? Yes, thank you. Thank you.
So let's see this one. So we want to factorize that, right? So again, you can say, all right, let's find two numbers, P and Q. P plus Q must be equal to -1, and P times Q must be equal to -12. What two numbers you think? What two numbers? You tell me. And just to give you a hint, the numbers got to be factors of the -12, right? Think of factors of 12, and you have to try minus signs inside.
So 2 and 6.
2 and 6 will add to give you -1.
Mm-mm.
3 -4.
3 and -4. Okay, let's see. 3 and -4. All right, let's see. So yeah, that will work. When you add them, you get -1. When you multiply, you get -12, right? So you write back this thing now as x squared. You want to go with -4x plus 3x minus 12, right? Then pair them up. I did this deliberately. I put the minus sign, the -1 before, because when it's here, it's troublesome, right? When you put a -4x this side, it gives you some problems. I'll show you just now. So I put a minus here. So I have this in the one bracket. Inserting the bracket here is no problem now. You don't need any change of sign because there's a plus sign here. I'll show you when the -4 comes here, what will be the problem. Okay, continue now factorizing. X is common there, so you get x -4. 3 is common there, so you get x -4. And then you bring your x -4 to the front, x plus 3. And that's it. Right? Good. So let me, yes, born.
Excuse me, sir.
Oh,
Pertaining to the equation before, right? Before this one.
It's
You
not
see,
it's not an equation, right? This is just an expression.
expression. You see, you have, right, x squared plus 5x plus 4, right? And then for the two numbers, it's going to be 5 and 4. For the P and Q,
No,
5 and
it was 5 and
4
1.
and 1, right?
Yeah, 4 and 1.
Good. So, how would the 5x just disappear when we come over this one side by right hand side?
It didn't disappear, it's there.
With the 5 there, I see the 5.
4x plus x is not 5x.
Oh.
You understand?
Remember, X is 1.
Okay, thank you.
Yeah. It's just broken into 2. It's the same thing. It's just under a little disguise. And we do it deliberately, right? We do it deliberately in order to facilitate the factorization process. Yeah, it's a good thing. It's a good thing you're observing those things and questioning it. Unless you question these things and, you know, you're not going to get it. You understand? If you just, man, I'm going to understand it later. No. It's good that you're slowing things up and you're, anything that is bothering you, you're asking the question. That's good. Right?
Sorry, she didn't ask. I want to know.
You see, yes. It's just that the 5x is there. It's just that we split it in 2. Right? Some textbooks say splitting the x term. So we split this. But we don't split it anyhow. We split it in a specific way. Right? Everything we're doing with a purpose. Right? We do it in such a way that the 4x, the 4 and the 1 must multiply to give you this 4 at the end here. Right? Because there's a trick, there's a arithmetic trick in it all. Right? Mathematicians are, clever people, They're to be deeply respected. Look here. I was saying, what about if we had the -4 this way? Look at what will happen. You'll get x squared plus 3x minus 4x minus 12. When you are pairing them together, if you were to do this, if you were to put minus out there and you put 4x, you have to change this sign. It is as though you already factorize minus 1 outside. A lot of students get tripped up here, right? And that is why I'm telling you, to avoid that, bring this minus 1 here and put a positive 1 there, like I did, right? An alternative is you can do this. You can do x squared plus 3x plus, and in the bracket put minus 4x minus 12, right? It looks ugly for now, but it's going to work out eventually. But to avoid all of this, put a minus 1 in front here, man. You know? And save yourself that worry. Good. Let's look at one that in where we have another number other than 1 in front of x squared, right? Let's try one like that. So let's say you have, all right, you end up with I wanted one that all right, let me use this one. 8x squared plus 22x plus 15. Right? So let me put this down like we have to factorize this. So when you see there's a number other than 1 there, so your two numbers P, Q, right? P and Q, P, Q, they must add up to give you the 22, but they must multiply to give you not just 22, but 8 multiplied by 15. They must multiply to give you 8 multiplied by 15, which is what, boy? That's a big number. Why did I choose such a big number? 8 by 22 is how much? Huh?
120, sir.
120?
Yeah.
I get 176. Something wrong?
8 times
One
15, I get 20.
176.
I got 176. Yeah, 176.
Oh, are you multiplying by 8 by
It's 8 by
15 or 8 by
15,
22?
8 by 22.
8, oh gosh, it's 8 by 15. Oh gosh. Here, them time of night now, right? My brain does want to go into hibernation. Yeah. 120, not 8 by 15. Yeah, 8 by 15 is 120. I put in the calculator 8 by 22. Good. So we're looking for two numbers. When we add them, we must get 22. And when we these are two big numbers. I should have used an example with smaller numbers inside. Well, let's challenge ourselves, right? Tell me two numbers, when we add them, we must get 22. And when we multiply them, we get 120.
Sir, 11.
11 and what? Where you get 11 from, man? Where did 11 come from?
So not 11 plus 11 and then 11 times.
They will add to be 22, but they wouldn't multiply to give you 120.
No, then I give one. Then I give it.
Think. Think what is happening here. Can see it? Hmm? Go with 10 and 12. Isn't that true? 10 and 12, we add to 22 and multiply to give you 120.
Yes, sir.
Good.
Think yes.
So we are taking this now and we're writing back this here in terms of, okay, 8x squared plus 10x plus 12x plus 15, right? Now we pair them up. What's common there? 2x. So you'll get 4x plus 5, right? What's common there? 3, right? And you remember you're aiming to get a common bracket which you will pull to the front. And that's your answer. So you see that difference when there's a number in front here, right? You have you say there is a coefficient in front of x squared that is not 1. So PQ must be equal to that coefficient 8 multiplied by 15, which gives you 120. Good. Can I move this out? Let's deal with maybe a case where you have something like this. Some textbooks can write it like this. You're factorizing, factorize minus x squared. Let me go with minus x minus, go that. Just now, let me see. Sometimes they ask you to factorize it. I don't like to write it like this. I like to write it like this. 6 minus x squared, right? So the minus sign isn't sticking out there. But again, we're looking for two numbers, P and Q. The two numbers must add up to give you -1, and they must multiply. PQ must multiply to give you the number in front of x squared here is -1 times 6, which is -6, right? So you're looking for two numbers. When you add them, you get -1, and when you multiply them, you get -6. Can you think of those two numbers? What can P be and what can Q be? Hmm?
-3 plus 2.
-3, okay, yes. -3 and +2, correct, yeah. Right? They add to -1 and they multiply to -3, right? So I'll take this now and write it back as, okay, 6 minus 3x plus 2x minus x squared, right? Pair them up, 6 minus 3x, put that in bracket. 2x minus x squared, put that in our bracket. What's common there? 3. 2 minus x, what's common here? X. And these two brackets are the same, so you can pull them to the front. And you get 3 plus x. If you don't like how this looks, you can write it as x plus 3, it doesn't matter. Let's do a last one after this. Like this. Anybody still writing?
Yes, sir.
I could move it, or you're still writing?
Still writing.
All right.
You can move it, sir.
Okay. All right. Let's take a last one. So we have to factorize minus 5x squared minus 7x plus 6. I'm not going to rearrange it, right? I'm going to leave it just as it. Because I don't like looking how it looks. I like to, have no minus sign sticking out there, right? So, all right. We're looking for two numbers, P and Q. P plus Q must be equal to minus 7. And P times Q must be minus 5 by 6, which is minus 30. What are the two numbers there? Two numbers, when we add them, we get minus 7. And when we multiply them, we get minus 30.
Minus 10 and 3, sir.
Minus 10 and 3, yes, that sounds good, yeah. So our P can be 3, you said? And Q can be minus 10, minus 10, minus 10, right? So good. We're going to write back this thing now. Write it back with those numbers. You get minus 5x squared plus 3x. And I'm doing this deliberately. If I put the minus 10 here, you can get some complications. Minus 10x plus 6. All right. You'll have complications no matter what. All right. So factorize out here, you get what? All right, let's pair them up. And this, you'll see now why I don't like leaving it like this. And I'll rearrange this to show you how it looks much more elegant, right? If I put the minus out there and I put 10x, I have to change this sign here. You see complications, right? So now what do I take out here? I take out, only x is common. So I'll have minus 5x plus 3. Down here, take out 2. And you get 5x. What happened there? I have to take out x there. We forgot to change. Let me see. Take out minus here. You take out minus 2 there. And you get 5x. You're not going to get a plus. What's happening there?
Excuse me, sir. The square over minus 5x square. How you didn't put it back at the bottom? How so?
You're dividing this by x. I think what will happen here, you have to take out minus x. And that will change this to plus, but that will change this to minus. Right? So let's see, let's do that. If you take out minus x here, let me erase that. So if you take out minus x here, you will get 5x minus 3. And if I take out here minus 2, I'll get 5x minus 3, right? Oh, I see what's happening here. I see what's happening in this situation. All right. So this is what you'll get now. You take this and you end up with 5x minus 3 bracket minus x minus 2. But this is not done here. You can actually take out minus 1 from here, right? Factorize out minus 1 from here. And you'll get this. You'll get minus. All right. Let me write this the other way around. So I'll have minus x minus 2 times 5x minus 3. You have to take out this looks ugly. That's what I'm saying. It looks ugly. So you can take out minus 1 from here. So you get minus x plus 2 times 5x minus 3. That's what it looks like. Right? So this one is it's a harder one. It stumped me for a moment there. So I wonder if I tried it if I rearrange it a little differently. Yeah, I don't see, you might end up with the same thing. Because to get the common bracket, you have to do this. Yeah. Interesting. Yeah, Born.
Sir, can we do another example like this last one, Isa?
All right, I'll look for one. Yeah. Wait, I'm not done here. I want to do it differently. See if I'll end up with this complication. I just want to try something. So let me, can I take this off? All right, let's take this off. So if I write, as I said, I don't like how this one looks. I like to write it like this: 6 minus 7x minus 5x squared. So if I write this as 6 minus 30x what were the two numbers? Not 30, what am I doing? Minus 6 minus 10x plus 3x minus 5x squared, right? Let's do that. And then you pair them up. There's a single mosquito by my foot that is. I gotta kill it. Yeah. put that in a bracket, plus 3x minus 5x squared. Let me see if I'll avoid that complication like we had just now. So I take out what here? 2. 3 minus 5x, okay, plus, what's common here? X into 3 minus 5x. See what I'm saying? No complication here. So we have 3 minus 5x times 2 plus x. This person who wrote this green line here, they need to erase it. I can't erase it. So you see how we could have avoided that thing just now?
Yes, sir.
Let's do another one. Somebody asked for one more.
Sir, just one question again. In this thing, right? Whereby if you put in 5x plus 3, right? And 3x plus 5, right?
Come on.
Or 5x. Okay. So for this part here, when we
which part? Here.
All right, says yeah. 6 minus 10x plus 3x minus 5x squared, right?
Yes.
Good. So because it's 6 doesn't have an x next to it, we find a number that can go into both numbers.
Yes. In this case, it's just 2. Yeah.
And because x is at both places, we will put back the x at the outside.
Yeah.
Okay, thank you.
Yeah. I'm not finding one like the one. Let me see if I can. Yeah, let me see this one. Last one. So we want to factorize. What's this? Minus 2x squared plus 2x plus 12. Right? So you got different ways you could have done it, right? All right, let's go with, what is it? Let's call, okay, PQ, they must add up to give you 2, and PQ must multiply to give you minus 2 by 12, which is minus 24. So tell me what P can be, what Q can be. They must add to give you 12. They must multiply to give you minus 24. What are the two numbers?
So what's the question? Sorry.
You have to look for two numbers. You haven't picked up yet, man? When you add them, you get 2, and you multiply them, you get 24. Minus 24. What are the two numbers?
When you add them,
it's written right here, you know. When you add them, you get 2. When you multiply them, you get minus 24. Can you think of two numbers? Huh?
Sir,
I'm not hearing what you're saying.
4, sir. Positive 24.
Sir, 2.
I'm not hearing you.
Sir, negative 6 plus 4. Is it 2 and 12?
Negative 6. Okay, somebody suggest. Somebody suggest negative 6 and positive 4. Sound okay, yeah. Right? So we can write back now, all right, minus 2x squared, and from experience, I'll use the positive there, right? And I'll put the minus 6x here, plus 12, right? What if I do it the other way around? Let me do it the other way. See. I say play dumb. Right? Go with minus 6x plus 4x plus 12, right? So we pair them off. Pair them off. So down here, minus 2x is common. So we get x plus 3. And down here, 4 is common. So you get x plus 3 too. Bring this to the front, and you have x plus 3 times. I'm not going to put minus 2x plus 4. I'm going to put 4 minus 2x. All right, so this one didn't give us some hassle. Follow it?
Yes, sir.
Good. All right, so I'll just touch on now is what, 634. You all want a short break and then we come back, or go straight through?
Okay, sir.
You want a break?
Yes, please.
All right.
Yes,
So
please.
we come back at 6:50, right? Now it's 6:35.
Okay, sir.
Okay, sir.
Good. So let's do a little more factorization. What we're going to look at now is what we call perfect squares. Perfect squares. Oh, that's a name. Okay. And let's examine something when we expand it, right? X plus a squared. That is x, sorry, x plus a times x plus a. Why am I going to write a everything first? Oh, and by the way, do not think that this here means x squared plus a squared, right? It's not equal to that. It means x plus a multiplied by x plus a, right? So I'll make use of my good friend's shortcut that she was talking about earlier, right? X by x and x by a, you'll get right. And I'll go a by x and then a by a, and I'll get ax plus a squared, right? And you get x squared plus 2ax plus a squared, right? So I want you to notice something about perfect squares. If you take half of the coefficient of x squared of x, which is 2a, half of this is a, and you square it, you get the n term. Right? Notice that. So anytime you see an expression, a quadratic expression that is, right? And in this case, we're talking about when the coefficient of x squared is 1, right? When it's not 1, it's a different scenario. There's some other properties or rules that govern that, right? We're talking here about a quadratic expression where the x squared term, the coefficient is 1. Whenever you see this property where the coefficient of x, half of it, when you square it, you get the n term, you have what we call a perfect square on your hand, right? And let me show you a couple of examples. So let's say you have to factorize x squared plus 10x plus 25. You could watch this thing and see that half of 10, when you square it, you get that number at the end here. So there's no need to go through the steps. You can go through it, right? Where you find two numbers, when you add them, you get 10. When you multiply them, you get 25. You could try that on your own. But you could watch this expression and see that, you know what, this is x plus 5 all squared. Right? You could watch it. Similarly, let's go with another one. X squared plus 8x plus 16. Again, you see the condition, right? Half of 8 is 4. 4 squared is 16. You can write this as x plus 4 all squared. And you can check it back. In your own little time, take this, multiply it out, and see if you don't get that. Take this, multiply it out, see if you don't get that. So if you can recognize, and not everybody can, right? If you're good, and you recognize that, well, you can save yourself that process, you know, of splitting the x term and finding p and q and all of that, right? Same is true. Maybe I'll give you a final one. Like, okay, you have to factorize x squared minus.
Excuse me, sir. Can you just go back to the page so I can... Thank you.
Let me give you a last one. Let's go with x squared minus 6x plus 9. Look at this. Right? Again, half of minus 6 is minus 3. Minus 3 squared will give you positive 9. So you can right away write x minus 3 all squared. Right? You have to develop that ability. Yeah? If you can't watch it and tell it, you have to do the long way, right? Find the two numbers. When you add them, you get minus 6. When you multiply them, you get 9, and so on, right? Good. So, all right, Lane, I think you're. Miss Lane, you're. Good. So the last thing we'll it isn't the last thing we'll do, but the last kind of factorization we'll deal with is what we call difference of squares. Difference of squares. Again, what they recognize, let me just show you something. If you have, okay, let's say you have x minus a times x, what am I writing? Certain time in the evening, my brain will start shutting down. X plus e, right? Look at this. Again, if we expand, we get that. Let's see. We get x squared plus ax Then we go with minus a times that times this here. And you're left with minus ax minus a squared. What do you notice happening here? So the ax and the minus ax cancels out one another. You see that? Therefore, if you see an expression of this form, right? I can put it like this. A squared minus b squared. If you see an expression of this form, it's equivalent to a plus b, a minus e. Right? So, for example, maybe we can do a few. We can do a few like that, right? I'll make use of this identity, right? So let's say you want to factorize x squared minus 9, right? Well, you recognize that to be x squared minus 3 squared, right? And you see it resembles this form here. So that's equal to x plus 3, x minus 3. So there's no need to do a whole set of steps. You're actually making use of what we call an identity. You see, I put 3 strokes there. This is identical to that. So once you recognize this, right? Once you recognize this, you know that you know what you're dealing with, a difference of square. And you could apply the formula. Of course, if you don't know how, you can actually do the longer way, right? Where you look for two numbers, when you add them, they're 0. And when you multiply them, you get minus 9, right? Which is 3 and minus 3. And you go the long process. Right? And this is a long process, just in case, right? X squared minus 3x plus 3x minus 9. Pair them off. X squared minus 3x plus 3x minus 9, right? Take out x, you get x minus 3. Take out 3, you get x minus 3. Pull that to the front, you get that. You don't need to do all of this. Why do this? Right? Once you can recognize that this is a difference of two squares, use the identity. Use that identity. Don't do this long approach you see here. Let me do an example or two. Maybe factorize 4x squared minus 25. Right? What do you see here? That's like 2x squared minus 5 squared. That's all. So this is the same as 2x plus 5, 2x minus 5, and that's it. Good. So why did we take so much time on factorization? Well, the simple reason is that there's something called a category of equation called quadratic equation, right? Quadratic equation. And one of the methods to solve quadratic equation is the method of factorization, right? So what's the whole idea behind this whole thing? Well, there's an idea that like this, right? That if two numbers multiply to give you 0, then either A equals 0 or B equals 0. Look at that and tell me if that makes sense to you. If two numbers add up, multiply to give you 0, then either one of them has to be 0. You agree? Now, what this has to do with quadratic equation and factorization and so on? Well, oh my. Somebody. All right, good. So let's see how we can make use of all of this to solve quadratic equations, right? So let's say you have a quadratic equation, x squared plus 5x plus 6 equals 0. And remember, your quadratic equation has to be equal to 0. Right? It must be equal to 0 for this whole thing to work. So when you take this, okay, let's say you have to solve by factorization, right? Good. So you take this, I'm going to skip over steps now. I'm not going to go through the steps. This would factorize to give you x plus 2 times x plus 3 equals 0. See? So this is like A, that's like B. AB equals 0, right? You see here? AB equals 0. Two things multiply to give you 0. Then either one or the other, or both of them, are 0. So we'll apply that here. If this product here, x plus 2 multiplied by x plus 3 is equal to 0, then either x plus 2 equals 0, and if that is so, x is equal to minus 2. Right? You just take that over there. Or x plus 3 is equal to 0, which implies that x equal minus 3. So your solution, x equal minus 2 or minus 3. One out of the two. So that's how you solve a quadratic by factorization. Remember, I skipped out all the steps. We spent all afternoon factorizing. So I'm not going to, go into all of that now. So we factorize the expression here, put it equal 0, and then we put each bracket equal 0 in turn and solve for x. Let's take a couple more. Let's say you have someone solve x squared plus 3x equal 10. Remember I said you have to make it equal 0, right? So that implies that x squared plus 3x minus 10 equals 0, right? So we're going to skip over that whole process of factorizing, and I'll tell you that this is x plus 5, x minus 2 equals 0. So I factorize here, right? So then you're solving now. Either x plus 5 equals 0, which implies that x equal minus 5. Or, we have to move this up a little, or x minus 2 equals 0, which implies that x equal 2, right? So your answer, x equal minus 5 or 2. Think you're getting it?
Can you pull on back screen a little bit? Thank you.
Good. Let's do a last one. Let's say you have something like this. You have to solve x squared minus 49 equals 0. Right? You recognize that as a difference of squares, right? X squared minus 7 squared equals 0. And we said you can factorize this as x plus 7, x minus 7 equals 0, right? So either x plus 7 equals 0, which implies that x equal minus 7, or x minus 7 equals 0, which implies that x equal positive 7. So your answer, x equal negative 7 or positive 7. That's the whole idea behind solving quadratic equations by factorization. Yeah, Born?
Yes, sir. So the 7, right? We getting the 7 from because 7 could go into 49. And when you times it 2 times, it give you back the 49.
And you square it, yeah.
Yeah, so that's how you just find the number for at the bottom here, right?
Yeah.
It's because go into the number that when you square it back, you will get back the number.
Correct.
Okay, thank you.
Good. So I think we're gonna pause there for the evening.
Yes, sir. My head hurting.